Now, I have the words functional neurology literally in the name of my clinic, which means that people ask me all the time, what is functional neurology? And I think perhaps the best, almost poetic answer can now be found in your 26-page paper. And so I just want to read what you wrote. I'm going to quote you and then let you introduce this model that you've been working on. You say too often conventional paradigms attempt to localize dysfunction to static lesions or binary findings. Functional neurology, by contrast, embraces complexity not as a problem to be simplified away, but as the terrain itself. That's beautiful.
Yeah, and it's meaningful. And one of the things you'll start to see is we talk about it a little bit in the paper, and we have another paper that's going to be going into peer review pretty soon about defining functional neurology. So that'll be hopefully another peer-reviewed paper to be the first ever published definition of what functional neurology is. And that was a byproduct of this paper. What we start to realize is that when we created this paper, we weren't really just identifying how to fix concussions. We were really defining what functional neurology is. We were putting a model around it. So as you kind of read, neurology had a very interesting past. Neurology was studied all the way back to the Roman gladiator days. Galen of Alcmaeon, which was one of the first physicians in the year 200 BCE, basically said, I'm studying the brain, and he thought that the brain secreted fluids that filled up muscles, but he thought this organ over there pumped fluid down through tubes into muscles into your bicep to make your bicep contract. So he had this idea that the brain controlled the body. That was the first real evidence of studying neurology. If you go back further than that, ancient Egypt, they used to take people's brains out through their nose and discard them and put their or other organs like heart and liver in these canoptic jars and put them in the tomb with the mummy because they needed them in the afterlife. They didn't need the brain, they needed everything else. So somewhere between there, the brain became important. And then we have this gap in time all the way until the 1800s and 1900s. In that period of time, I'm not going to go too deep into this, but realistically, the father of neurology was Jean-Marie Charcot, who practiced at the Salpêtrière Hospital in Paris, France, and he basically was the first to perform a neurological examination. The reason why I'm sharing this is that that was when the neurologic examination was born. Touch your nose, look at pupils, follow my finger, all of these tests to figure out what exactly is this organ inside the head that we can't see. What is it doing? How is it functioning? How is it working? Is it broken? And function was tested in neurology all the way till 1971. Every neurologist did a neurological examination, pinprick, muscle testing, reflexes to figure out what the brain is doing. In 1971, the CT scan was developed. And for the first time, neurologists can see pathology in the brain. And when you can see something in literally black and white, it becomes more tangible. It becomes a little easier to diagnose in some cases, but also beneficial for things that we need structural neurology for. So there was this bifurcation in neurology with structural neurology, and then this neurology of assessing function like EEG and things of that nature. And inside that gap there between the measurement of neurological function and structural neurology lives a lot of people. People with migraines, concussions, autism, ADHD, all of these people have neurological problems with nothing on a CT scan or an MRI, right? So what happens to those people and how many are there? Well, the estimates are that there's about 1.3 billion people in the world that have some sort of a neurological problem that is not structural. And those people get caught in this gap because they're told that they're crazy or they need psychological care or there's not really anything wrong, you're perfectly fine because there's nothing on the imaging. So that's what I meant in that quote when I say that all too often we start looking for structural pathology or things are binary, you're either healthy or broken. And it's not really that simple. And that persisted all the way into the early 90s when the fMRI was developed. And now structural neurologists are able to start seeing functional changes. And now we're kind of getting this convergence again into what we're calling functional neurology, right? But when we start looking at function versus structure, and it's not to say that they are separate things. They must coexist. We need to know when somebody has a tumor. We need to know when somebody's having a stroke. But the thing is we can't just throw all those people that don't have structural problems to the wayside and say there's nothing wrong with you. We have to have a model that explains them. And I guess the fortunate thing, but also the fortunate thing that there's nothing structural wrong, but the unfortunate thing with nothing being structural is that there's nothing tangible to say this is the problem. So how do we determine what's wrong with them? Well, we have to go back to doing a really good physical examination. And that's where our model started. Our model started with how can we start to how do we model what happens when somebody has a shaking of their brain and they're not functioning properly? Where does it all start? And how does it unfold if there's nothing there on the imaging?
Yeah, that's a big task. And I think you did a fantastic job of really piecing this out system by system and going back to that trajectory of even how people learn neurology. As a student learning basic neuroanatomy, it's like you learn the different lobes of the brain, and oh, the occipital lobe is where we have vision and the frontal lobe is where we have executive function. But the reality is that vision is a whole brain activity, sound is a whole brain activity. And so even the way that I think we teach neuroanatomy, it's still feels like the teaching of it is so localized, and there could be a whole entire discipline of just functional neuroanatomy that has to be a foundation before people can even understand your paper.
Yeah, I mean, that's kind of true. And I think you hit the nail on the head there. Like humans by nature are very reductionist. We like to understand pieces, right? And it's nice and easy to understand pieces. It's understand that the frontal lobe does this, the occipital lobe does that. But what ends up happening, and that is really great for things like structural neurology. Okay, the frontal lobe does this. We have a big tumor in that frontal lobe. This is why you can't do that. That makes perfect sense. However, what we're starting to realize is that the way that the brain actually works, well, let's put it this way. We've understood the way the brain actually works outside of medicine for a long time. And what I mean by that, if you go on your computer, go to ChatGPT or Claude or any of these types of Gen AI softwares, you go and put something in there and you ask it a question. And basically, what it does is it queries something called a neural network, right? And it's like, wait a second, that sounds pretty familiar. Neural meaning brain, network being a collection of information. So AI is based upon how our brain actually functions. I always kind of say functional neurology is neurology plus graph theory. So
Uh,
it's just understanding how the anatomical structures talk to each other and function together. And if you understand how they function together, you understand how they dysfunction together and how to put it back together. So that's kind of the basis for all of this.